All right, guys, welcome back. Today is day 2 of Unit 1, Lesson 4. So let's get started. We're going to need our lesson book, a pencil, a notebook, and we're going to be on page 30 and 31 of your lesson book. So let's recap what we did yesterday. So with day 1, we looked at large numbers and we shrunk them down in our little accordion and rewrote them in scientific notation. Well, today we're going to talk about positive and negative powers of 10 and how different is writing the small numbers and decimals than large numbers, but we're still going to write them in scientific notation. Okay, y'all ready to get started? All right, let's go. So let's make sense of this problem. 7 nanoseconds is equivalent to 7 1/1000ths of a second, or blank second. Write blank in scientific notation. Let's read that one more time. And then I want you to think about what we're doing, how different this looks from day 1, and some of the things that you notice that are really important, okay? 7 nanoseconds is equivalent to 7 1/1000ths of a second, or blank second. Write blank in scientific notation. So in your notebook, I want you to pause my video and write all the things that you notice that are important, and write them down in your notebook. So pause me. 3, 2, 1. Okay. All right, so let's see what you did. Let's see how you did. So obviously, I still have my numbers hidden, but let's see if we found the same things, okay? So 7 nanoseconds is equivalent to 7 1/1000ths of a second. Did anybody catch that right there? It doesn't say billion, it says billionths. And what do we know about the THS numbers? You got to think way, way, way back, right? This is what in elementary school, right? Where we learn, what is it? Place value. How important was place value on day 1? Like really important. That's all we talked about was place value. What do you notice about this place value? And I want you to think for a moment, where do you think it's taken us? Is it taking us to a big number? Or are we going on the flip side of the decimal and it's going to take us on the other side of the decimal, right? Hopefully that's where your thinking is. That's exactly right. It's going to a billionth, right? Like, whoa, okay. And then hopefully you notice we're going to rewrite it in scientific notation. So let's think about what that looks like again, right? Before we pull up these numbers. What is that first number of our 2 products, right? We have one product times another product. So what did that first number look like? Do you remember? Okay, hopefully you remember that it was a number that was greater than or equal to 1 and less than 10, and it can definitely be a decimal. Absolutely, okay? And then, so this number had to be greater than or equal to 1. You know what? I know what I'm going to do with you guys. I'm going to rewrite it like this. Here's my 1, and it had to be less than 10, right? So it has to be less than 10 and greater than or equal to 1. So that's what my number can represent. Why not throw in some inequalities in there, right? Okay, and then we're going to be multiplying it by, what are we multiplying it by? When we looked at our objective, didn't we talk about powers of 10? Do you remember the powers of 10? Yes, so it has to be a power of 10, and that's where I have my base. Here's my base, and then I have that little bitty exponent right there. And remember, that exponent tells me how many times I am multiplying it by itself. Okay, now let's uncover that number. See what we got. That looks like a lot of zeros. A whole lot of zeros, doesn't it? Okay, so what I want you to do before we jump into this, I want you in your notebook, I want to see if you could rewrite this in scientific notation before we even get started. Let's see where your thinking is and how close it is. You might have like totally rocked day 1, And this lesson, you're going to get it like so fast. But let's just see where your thinking is, okay? So I'm going to put my little decimal friend where the decimal is. And I want you to tell me, no, not tell me, I want you to write it in your notebook. See if you could write it in scientific notation by yourself. And pause me. 3, 2, 1. Okay. How do you think you did? Well, before I just throw the answer out there, let's look at some different ways we could do this, okay? So one way, if you remember day one, you might have just moved your decimal. So let me take my little decimal guy right here, and let's see how we're going to move him, okay? 1, 2, 3, 4, 5, 6, 7, 8. If all we did is count zeros, that'd be 8. Is that where my decimal needs to go? Does he need to go in front of the 7? Because would this satisfy the greater than or equal to 1? You're right, it would not. It would not satisfy. So if it took us 8 just to get there, right, wouldn't we have to go one more? And you would be absolutely correct. We do, right? So how would this look scientific notation? So I know my powers of 10 is how many times I'm moving my decimal, correct? How many times did we move our decimal? Let's try that again and count one more time. 1, 2, 3, 4, 5, 6, 7, 8. We moved 9 times. 9 times. Now, I know that 9 has to go here, but we're going to talk about whether he's negative or positive, okay? We're going to talk about that. So I'm going to leave this guy alone for right now. I'm going to leave him alone for right now. And then what number is going to go right here? We talked about it, right? Do you remember? Good. Hopefully you said it's a 7. Okay, that's exactly right. Now, if I just wrote this number in scientific notation, knowing what we did on day 1, let's look at what type of number that would be. So I'll move you up there. There we go. Okay. Okay, so if that's all I did, what would my number look like? Let's see. Well, we definitely have a 7, right? And then my decimal is here behind. So when I move my decimal, what happens? 1, 2, 3, 4, 5, 6, 7, 8, 9. If I fill these in, what's happening to my, look at where my zeros are compared to my number. Do you see this? Do you see where my zeros are? They're behind the number. These zeros that we're trying to figure out are in front of my number. And there's also a decimal. So let's talk about how this number is supposed to look. That's what we're dealing with today. And that's what's important for us, okay? So let's look at that. So we're going to look at a different way of thinking, okay? And a different way of looking at it. Did anybody think fractions? So if I look at this chart, hopefully you're familiar with this, something very similar that I did in lesson 1, because we talked about negative exponents and positive exponents, and we also talked about how these relate, right? We are always, there's always a 1 on the bottom. We are always dividing by 1. So even when I have no numbers, 0 tens, we are always going to have a 1. So please always remember that any number to the 0 power is always 1. He is like the loneliest number that will ever live because he's always by himself. Okay, so let's look at this. What do we have on this side? So we have whole numbers up top, right? And then it goes down, and look what happens. We've got decimals. In lesson 1, we definitely talked about how our fractions relate to these guys right here, right? We definitely talked about that, and that's very important that we remember that, because today we're going to practice rewriting that negative exponent with our reciprocal. If you remember that from lesson 1, we'll go back and refresh your memory on that too, okay? But let's look at how this works. So with my exponents up top, this guy, this exponent, it's repeated multiplication. Repeated multiplication. But as I go down, it's repeated division. So understand that that's what this is. this exponent, it's the opposite. It's my inverse operation. So instead of repeating multiplying, I'm going to be repeating division. And you know, when we divide, we get fractions. In lesson 3, remember how we talked about converting fractions to decimals and how we have to divide? This is how these work, okay? All this is a division problem. 1 divided by 100, which gives me 1/100th, right? Okay, so we're going to do the same thing that we did in lesson 3 also, and let's go ahead and try to convert that decimal into a fraction. So let's go back here and see if we could do that, because I want you to be able to understand why we're moving our decimal and why is it negative. It's not just good enough to go, well, I'm going in the opposite direction. So no, there's a reason why it's negative. So let's look at that. So let's go ahead and make our fraction, right? So there's our fraction bar, okay? And on every single number that exists in the universe, there's always a 1 underneath it, always, always. Because we're always dividing by 1, that's how we get what's there. I like to put my 1 in the ones column. So I did. I put them in the ones column, dropped them in there, and I'm just going to go ahead and get rid of them, okay? This is going to help me with my place value. So my first 0 tells me this is the tenths place. I'm right, yep. Next one is going to be my hundredths place, thousandths, 10,000ths. You see how this works? As I'm adding my zeros, that is my place value. Isn't that amazing? It's really cool how that works out. Okay, so let's go ahead and I'm going to white out. I love whiting out. I'm going to white out all these zeros because now this is what I'm left with. I'm left with 7 1/billionths. Okay, don't forget my commas. 1, 2, 3, 1, 2, 3, 1, 2, 3. I want you to look at this. You know what a fraction is and you know what a decimal is. Now compare the two. So here's my decimal. Here's my fraction. I could rewrite it, can't I? Okay, I could rewrite it as 7 times a fraction, right? If I divide 7 away from here, okay, I could get 7 by itself times, oh my goodness, we're looking at writing it almost in scientific notation right now, aren't we? But watch what I'm going to do. I'm going to work you in, okay? So if I divide 7 and 7, I'm going to get 1. Let's talk about what's on the bottom. And I need you to think from lesson 4, day 1, how I'm going to rewrite it. We are talking place value, even though right now it seems like we're counting zeros, but we are not. We're moving our decimal and we're counting place value, okay? We already know that it's going to be something, we're going to have 9, and that's okay. You're thinking about that right now, and that's awesome. So let's see how many 10s we're going to have. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9 10s. And it's the same, but I want you to look at what happens. That 1 over 10 to the 9th, that is more accurate and correct than our first one. Okay, because it's a fraction, right? This is it. This is our fraction right here. So how can I rewrite this fraction? So let's talk about that. Okay, so we're getting close. We are learning. We're getting closer. And it's all going to be worth it, I promise. As soon as we understand that if I can rewrite this, right, here we go. So so we have 7 times this. Now, I'm going to remind you of how this lesson goes. This was all the way back from lesson 1. So in order to rewrite this, we have to rewrite it using a reciprocal. A reciprocal is when I take my fraction and I flip it upside down. So the reciprocal of 2/3 is the idea of taking that 3, popping them up top, taking that 2, popping them down below. These are reciprocals of each other. They're completely upside down, right? Okay, so a reciprocal of this fraction is exactly the same thing that we're looking for, but there's a other little step that we have to do because of this exponent, okay? we have to prove that it is dividing, that it is repeated division, because 10 to the 9th does not equal 1/10 to the 9th. They're not equal. We just proved that, didn't we? This is a large number, and this is a decimal, which made it really small. So what kind of number exponent am I going to use? So let's see. So let's take this fraction, and we're going to flip it. We're going to get that reciprocal. So what happens is this 10 to the 9th jumps up top, and that 1 jumps down below. But here's the step we can't forget. Once that exponent jumps on top, it becomes negative. Now, do I need to keep the 1 under bottom? No, because anything divided by 1 is itself. So what I'm left with is 10 to the negative 9th. This is what we are doing today. That is how and why it has to be negative, right? Okay, let's try to break down another problem, very similar. Okay, or you know what? Before we do that, let's do a little extra practice on rewriting. I'm going to give you a few different ones to rewrite. So let's do this one. Can you rewrite this as the reciprocal? And remember, that exponent changes every time it flips up or down, okay? So pause my video and in your notebook, rewrite this, please, using the reciprocal. 3, 2, 1. Let's see how you did. I always draw my oh, wait a minute. There's nothing underneath that, is there? What always goes underneath? I told you he's the loneliest person, right? The loneliest number ever. That's my 1. He's always there. We might not see him, but he's always there. He's going to jump up top. This 10 to the 6 is jumping down below. But what happens? These two have to be opposites. Everything, when we inverse it, everything is opposite when we're talking about exponents and my reciprocal, okay? Let's try one more, guys. Let's see how you do. One more, okay? Let's go backwards this time. What if I did, oh, let me get out of that yellow. Okay, let's do one more. We'll have a fun one. Pause my video and give me the reciprocal. Go. And 3, 2, 1. Let's see how you did. Okay, this time I gave you the fraction. So did you put that 10 to the 19th and make it negative? Good. I don't need that 1 underneath, but if you wrote it, that's fine. But I prefer just this answer. Okay, I think we're ready to move on, guys. Let's go. So how do you know, make sure you can read my little, how do you know now that we've had some practice, how do you know when an exponent is going to be positive or negative? This case, I would like you to talk out loud. You might want to find your mom, dad, aunt, uncle, anyone that's in the house, even if it's an animal. Grab a pet, grab your dog, talk to them and tell them, how do you know an exponent is going to be positive or negative? Pause my video and talk about it, even write it down in your notebook, okay? Pause me and think about it. 3, 2, and 1. Okay, let's talk about this. How do you know when I know, did anybody come up with this? What if my number is negative? That means my exponent has to be negative, right? What if this number is negative? That exponent has to be negative, right? Because Ms. Leo said that, you know, it has to be greater than or equal to 1, and if it's a positive exponent, my numbers are going to be big. Okay. It's not true though, right? I did say they were going to be big as far as where our decimal place value is. But when it comes to the positive or negative exponents, hopefully we were thinking this would be positive, and a negative exponent is going to give me a decimal. How'd you do? Okay, if you're still stuck, that's okay. We're going to do some more practice, okay? And we're even going to blend them all together. But my positive exponent, my zeros are going to be behind the 1, just like, behind the number, just like I did here. Whereas my negative exponent, my zeros are going to be in front. That's the difference. Okay, decimal, fraction. Okay, and let's talk about where these numbers fall. Let's see if that might help us with our notes. So my question is, and this is where I'm getting at, is with my negative exponents. Is 2.14 times 10 to the negative 5th power at least 1 or between 0 and 1? So this is where we're going, and I want to know kind of where I made you think about your positive or negative. Think about this, and I want you to tell me, is that at least 1 or is it between 0 and 1? Okay, I'm going to give you a few seconds, but I'd like you to pause me. That way you can write on your notebook how you feel about this, okay? And try your best to explain. Okay, 3, 2, 1. Let's see how you did. So, my first thought might be that this 2.14, oh, he's definitely bigger than 1, right? So it has to be at least 1. Okay. Anybody catch this -5? So I don't know. I know it can't be this one, but I'm not sure about this one. Okay, let's look into it, and then we'll come back to the explain. Okay, so let's break it down some. So why don't we write this 2.14 times 10 to the negative 5, write this in standard form. Pause me and see if you could write it in standard form. Okay, go. 3, 2, 1. Let's see. Okay, so did you do a decimal or did you do a fraction? So let's see if we're going to do it both ways just to see what you did, okay? Both ways are right, but I'm going to lean you more towards moving our decimal, but this is helping us understand this explanation right here too, okay? All right, so let's write this in standard form. So we're going to start here. Wait, no, I can't start there, can I? Which way is my decimal supposed to go? Well, he's definitely not going this way, is he? No, he's going the other way, so I'm going to rewrite him. Let's start on this side, actually. Okay, let me bring down that 1. Okay, so we're going to go, how many place value spots are we moving? Okay, we're moving 5, but we're not going this direction, are we? We're not going that direction. No, we got to go the other direction. We're going in the opposite direction as those big numbers, huh? Here we go. 1, 2, 3, 4, 5. That's where we are, right? 5 spots. There's my new decimal. So what are we going to fill in all those little loop-de-loos? Good. We're going to fill in our zeros. Good job. Okay. So it's really messy. We're going to rewrite that number, right? Okay. Let's rewrite that one, shall we? Okay. 1, 2. Okay. Look at this number. Okay. Did anybody write it in fraction form? Well, I'll write it just in case you did or didn't, because you could have, right? Okay. This is how a fraction form is going to look. So if I took this 2 and 14 hundredths, because that's how I would say it, my hundredths is going to be on the bottom. And then let's get rid of that little decimal right there. There we go. Okay. And I'm going to multiply again. But instead of 10 to the negative 5, I'm doing my fraction 10 to the 5th power. What? Bringing it back. Yeah, don't forget, I can do that reciprocal, right? So what's going to happen is when I multiply 214 times 1, that stays on the top. And then I've got 2 zeros and 5 zeros. That's going to give me 7 zeros, which, watch how cool this is, okay? I'm going to write all these. Well, we don't have to write all these zeros, but I want you to watch how cool this is. Let me get my little decimal guy out for this because he's fun. Okay. So in order to understand the 7th, watch this. You ready? 7 zeros, right? And I got to include all of these, right? Here we go. 1, 2, 3, 4, 5, 6, 7. How cool is that? Okay. I just think that's pretty amazing. So wait, decimal guy, you're going crazy. Okay. So this 7 is my place value. You didn't realize place value was so important. You've been using it forever. I've got to remind you, this is where it comes in play big time, okay? So you might have only moved it 5 times, but this number has a different meaning, right? I have 7 decimal places to the end. Very important, okay? We wrote it in standard form by moving. Okay, so let's look at this and see if we can actually talk about our explanation now. Let's see. So let's go back to our original question, and it says, is it at least 1? Is this at least 1? No, it isn't. Okay, but is this number between 0 and 1? Yes, good. It is between 0 and it's kind of a far away from 1, but it is between 0 and 1. Okay, y'all are doing amazing. Good job, guys. Okay, is your mind blown yet? Because I'm telling you, it's pretty amazing stuff. So what I want you to do, let's go back, and we're combining lesson 1 and 2. Day 1 and 2 for this, okay? So in your notebooks, I want you to write this number in scientific notation. And remember, you've got a positive and a negative exponent. So figure out which one you're going to need in this situation, okay? Okay, pause me and rewrite it for number 10. Go. 3, 2, 1. Let's see how you did. I'm going to move mine and see if you got it right. How'd you do? Did you count 1, 2, 3, 4, 5, 6, 7? Okay, because here's the thing. If you only counted 4, shame on you. Stop counting my zeros. We're looking to count space and place value, okay? Place value is very, very important. All right, let's try another one. This time, I want you to flip it, and I want you to write it in standard form. Pause my video. Go. 3, 2, 1. Okay, this is a negative exponent. Did you make your number negative? Or did you make it a decimal? Hopefully you did the decimal. So let's see. So start with 9.054. And remember, if we're making it into a negative, we got to start him a little further down, right? And how many times are we moving him? We're going to move our decimal 6 times. 1, 2, 3, 4, 5, 6. Ooh, my little loop-de-loops are a little crazy. Okay. So this is what we're looking at. Okay. How do y'all feel about this so far, guys? Are we doing okay? Okay. Hopefully we are doing great, right? Okay. So let's look at this. Got a couple of these questions. It says, which of the following expressions is equivalent to that big old number right there? Okay. I want you to think about this because Carson chose A as his correct answer. I want to know, how did he get that answer? Notice I didn't say, is Carson correct? I want to know, how did Carson choose A as his answer? Pause my video and do one of two things. One, I want you to find out which expression is equivalent. 2, I want you to figure out if it's the same answer as Carson, and if it isn't, what did he do wrong? Pause my video, go. 3, 2, 1. Okay, let's see how you did. So, there's a whole lot of numbers, and you know what? I want to talk about how to get rid of one right now. How many zeros do you see? I see 6. And I keep stressing and stressing and stressing. Don't count the Zeros. Good. Okay. Eliminate 2 answer choices right now. Right now. Did you eliminate C? Good job, because it had a 6, huh? All right. Now, what is a great reason to eliminate B? Not just because of the 6, but because it's it's got a negative exponent. Okay. All right. Good job. We got 2 answer choices out of the way. Okay. So one is the right answer. Oh, wait a minute. One is Carson's answer, huh? What did we talk about when we talked about positive and negative exponents? A positive exponent is going to do what? He's going to give me a big number because my zeros are going to be behind, right? Behind my number. Whereas my negative exponent, what's that going to give me? Hopefully you said not a negative number, but a decimal. This is repeated division. So if I'm going to divide by 10 9 different times, that's going to give me a lot of zeros in front of, right? Okay, let's try one more. Okay, this is going to be, so which is equivalent to 8.3 times 10 to the negative 8? So see, I kind of flipped it. Now I'm giving you scientific and I'm making you find the standard. So Eva chose D as the correct answer. I want to know, how did she get that answer? So how do I want you working this? Number 1, why don't you try to rewrite that number? Okay, that'll help. And then I want you to figure out how Eva got D. So if y'all got the same answer, there you go. But if not, how did you get D? So pause my video and go. 3, 2, and 1. Let's see how you did. So let's rewrite it. Oh, wait a minute. Let me put the right numbers in there. And I'm going to move it over because it's negative. So if it's negative, that means I'm going to have a what? I'm going to have a decimal. So my number is going to be small, and it's going to be between 0 and 1, okay? So here we go. Oh, wait, how many times are we moving this decimal? Good, we're moving it 8 times, but we're moving it to this direction, right? Okay, and you know what? I don't know if y'all noticed this, but watch this. If I made a number line, let's pretend that this is 0, or where my decimal starts. What kind of numbers are on the right side of 0? Did you say positive? Yeah. And so when I write when I go from scientific to standard, do you know which direction your positive exponent has you go? To the right. Did anybody notice that? Guess what direction we're about to move our decimal on this negative exponent? We're going to move it to the left, aren't we? And what numbers are to the left of 0? That's correct. Negative, right? Negative. So check this out. Okay. We're going to move it 8 times in the left, right? 1, 2, 3, 4, 5, 6, 7, 8. Ooh, my loop-de-loops keep getting more out of control. Oh, that's a lot of zeros. 1, 2, 3, 4, 5, 6, 7. Oh, okay. Look at our answer choices. Look at our answer choices. And my number is crazy. I get that. Okay. But I think there's only one that really shows this number, right? It has to be B, right? Okay, no, it's not B. Is this a negative number? Nope. If this was negative, then yes, it would change and I could choose B, right? But this isn't negative, and that is possible. But in this case, did you guys see? Because I hope you did. That would be awesome. And look at that silly Eva. Eva chose D, and that's okay, right? But what did she do wrong? Can you find it? She went the wrong direction. She treated that 8 as a positive exponent, okay? So y'all did great today, guys. Y'all did really good. So tomorrow is going to be our day 3, and we're going to go more into it, and we're going to actually start comparing them. So good job today, guys. See y'all soon. Bye.